Hello again. Welcome back to our latest podcast on really providing third-party support or compute support in our lifecycle management. My name is Kevin Culp from Supermicro. I'm here to jump into the sandbox today to give you sort of a overview of how we actually build our unified dashboard story for open distributed infrastructure management. In the previous video, we discussed how we walked the Redfish endpoint, collected very important metadata, and collected that particular metadata and built it into our front-end dashboard to provide the user with a fantastic end-user experience for server architects. So today we're going to log into the sandbox here. Or jump into the sandbox and log into the landing page. So we'll first of all change the domain. I have set up a domain here called scc-demo.org, and this is a domain we set up on our AD that authenticates most of our customers that are evaluating our product into our own sandbox here. So we have a customer demo lab that you can jump into and get a feel for how the product actually works. So I've set up an account ahead of time called CulpK, and we'll authenticate against that user, and then we'll plug in our password here. And once we plug into our password, we'll immediately taking into the read-only high-level dashboard that shows essentially alarm statistics and various different useful information that a network operations center would basically be looking at of actually providing support for data center. So sort of the watchman that's looking at the data center and making sure it's functioning for an enterprise. So the first thing I want to kind of point out to you is we are indeed logged in as CulpK as a username. So we can go ahead here and look at the profile itself. And you indeed see that I have the role assigned to me as global admin, and the account is set up for CulpK. If you wanted to get fancy here and put your picture there, or your favorite dog, or your favorite girlfriend here, then you could certainly go ahead and put it up there in that area. Or if you have your spouse, you can certainly put there too as well, depending on how you want to do that really. As well as the other thing you want to take a look at here is really this idea of online help. So we've built this into our product here to provide you the ability to look at what we call the command center, the support center that helps you navigate through the GUI interface itself. So by clicking there, you'll be able to see information about the support center or how you would navigate around the platform. There's indexes set here so that you can look at various different content to help you perform your tasks within SuperCloud Composer. So let's get back to the dashboard here. And the first thing I want to show you is really our hallmark feature called Pod View. So I've talked about this in previous videos, but I thought I'd quickly go through this again. Maybe perhaps you're looking for a specific use case associated with SuperCloud Composer. You don't want to go through all the videos that we've posted. To date, I believe there's somewhere close to 160 videos that talks about different use cases. So I welcome you to go out, invite you to go out and look at that particular content that really would maybe resonate for a specific use case that you're looking for in the enterprise. So let's start by clicking on the default racks. The first thing is we want to look at a PDU rack. So yes, we provide PDU management for a rack, all the telemetry, analytics, all the lifecycle management for a PDU. I'm not going to get that in today. There's a whole video that really talks about PDU management associated with our platform. So we're looking at support for a universal agent PDU that's going to go out and basically provide support for PX4, which would be your Legrand type of PDU, Schneider Electric for APC and server tech, and then also, of course, Eaton. So we're covering the big manufacturers and vendors that support PDU. There may be other ones that might be of interest to you that we are building in as a unified agent. So the first thing is it really shows you here that a PDU has been assigned to this rack. There are different particular regions of what we call the rack, and we provide that level of detail there when you're looking at pod view. So here you're seeing a PDU that's been associated with this particular rack. It happens to be a Schneider Electric SKU AP8641 type PDU, and it's a smart PDU. It does all the bells and whistles that a PDU, you would expect a PDU to be able to do there. So we're going to click on the PDU rack itself, and immediately we start rendering or start providing you a visualization of the information inside the rack or a display of those servers. And the two we're looking at today, we have, of course, lots of Supermicro servers in this particular rack. Everything from big twins and storage servers and 1U appliances such as rack mounted, so on and so forth. So all of this is inside our PDU rack, and the first ones we want to take a look at are really our HP, which is a ProLiant server that we were looking at with the walking of the Redfish endpoints that I previously discussed in the previous video, and then also our PowerEdge server, which is Dell, which we have inside our particular rack. So each of these have been provided a static address. You can, of course, do DHCP if you wanted to on these, and we would be able to support both DHCP and static. As I mentioned in the previous video, because of the Redfish support, we're able to provide an open standard-based platform that we can go collect this metadata. Of course, we can only provide the necessary lifecycle management that they expose within Redfish, and providing, deployment. You'll see in the next video, deploying an operating system to this server, and then collecting specific metadata for each of these servers. So as we continue to start in the industry, gathering momentum and interest in Redfish, which is actually moving, we believe that our friends across the aisle will provide a lot more rich Redfish information in their platforms so that we can expose that kind of information to support third-party support in an enterprise. Most of the platforms or data centers out there provide many vendor support because they don't want to be locked into a specific vendor. So we're providing that open standard-based platform that you can go ahead and support your data center. Of course, we'd like you to have all Supermicro gear in your data center, but we know that that is sometimes not something administrators are looking for. So we are looking at providing you with an open enterprise platform that supports your requirements and needs within the enterprise. So let's now, after we look at each one of the HP systems and also the Dell, let's look a little deeper at each of those and see if we can gather the metadata we need to at least look at some additional information within the platform. So what we provide here is a front and rear view of the image. It's rendered through our what we call vector formatted library, so that we provide a look and feel of what the server looks like. I think it's important that you provide this information a visual, because we're typically people that need visual type cues. So I think it's important that we provide that level of detail and visualization of a server. To the right of it here, we also provide system information associated with this PowerEdge server. Some of the information has been collected through what we call parsing of the Redfish endpoint through the source of truth being the iDRAC 9 itself. And then when you actually go through and register this within the drawer configuration or within pod view, then there will be additional information that you will be prompted to add in. So one of the other areas I want to point out are very much different than how our third-party devices support what we call SSDP, or what we refer to as a ping spray. So, excuse me. So we add in this manual information through what we call the manual pool. So we would add in information specifically here about adding in your system switches, and of course you see adding in our CDU, which is our liquid cooled data center in this example. We won't get into that, but we add in our system and switches, which are third-party devices, and then you would be prompted how to enter in that information within pod view. So all of this information gets added when you actually register the device within the manual configuration of pod view. So if you wanted to go up to the drawer level is 4. So what does that mean, the drawer level? Well, what it is we actually provide what we call the rack slot unit. So if you're having a 42U size rack, you have numbers on the left-hand side and right-hand side of the rack that are numbered 1 through 42. And based on the form factor of the device, we occupy those appropriate rack slot units of measure inside the rack. So we're starting at position number 4 of rack slot unit 4, and we basically depict that in our drawer configuration. If we wanted to look at the next level up, we would basically click there. So this happens to be a 1U device, so it occupies 1 rack slot unit. It would basically utilize the rack slot location 4. Now, if you wanted, you could change it if you wanted to a different particular drawer location. Perhaps you're moving them around from different particular racks, from one rack to the other, or from one rack slot unit. All of this is possible through pod view. It's a logical representation of how your data center is organized. So nothing magical is happening here based on dynamic type stuff where you're moving workloads and you're moving basically VLANs and all of that kind of stuff. It's typically a very logical representation of how you're going to organize your data center. And I would expect before you start your manual configuration, or when you start actually designing pod view, you have a rack cable implementation already implemented, where you can make sure that each of those devices that are in those specific racks truly are in those physical slots, right? So there need to be some type of work done there to make sure that your pod view is a true representation of where those devices are in your rack. All right, so other areas you can do is moving it into a different particular rack. Of course, here we're just using PDU rack itself. And then also the ability, if you wanted to change it or associate it with a pod. We talked about in previous videos of a pod is a group of racks or a logical representation of workloads that exist. So you might want to group your workloads associated with a particular pod, such as a VMware farm where you're actually using all your hypervisors and your data centers built for your VMware cluster. Or maybe you're actually defining a Hadoop cluster or an Oracle rack where you want to basically organize those workloads associated with a pod. Or maybe it's a GPU farm where you're doing all kinds of inferencing and you want to associate all those servers within specifically that rack itself or that group of racks. All right, so there's a little bit on the PowerEdge server, which is the Dell. So we're now going to look at the ProLiant server by HP. Again, we render the Visio image to show you the front and rear view of the ProLiant server. We provide you metadata here within this this particular ProLiant server. Both in the Dell example and any example, whether it be a Supermicro server or a Dell server, you can click on this particular button here or this particular connection, and it will automatically go to the ILO in this case because it's a ProLiant server. And then if you were to click on the Dell option, it would be basically going to the iDRAC connection itself. So each of our vendors have a base management controller. They refer to them as ILO on HP, and on basically Dell they refer to them as an iDRAC. And we at Supermicro refer to our particular base management controller as BMC. So if you're first coming into the game here and you really don't understand what these are really the ability for you to manage that particular server itself. You would get into a whole different type of GUI that is able to manipulate, where you can go ahead and look at alarms. You can look at specific components of each of those servers, various detailed information that you can extract to look specifically at a task you want to do with that server. So the intent of the management platform is to be able to do this at scale. In the situation where you didn't have an enterprise platform such as SuperCloud Composer, you would have to go to each individual ILO connection, iDRAC connection, or Supermicro BMC connection, perform that server lifecycle management per that server, and then click onto another option, and so on and so forth. So the intent here is for the management platform to extract or move all those tasks into one particular unified experience so that it minimizes the number of clicks and also various things you have to do. Of course, we provide that access into those platforms, but if we can provide a management unified experience where some of this information is already provided, then that is going to save you time and money, and you can quickly deploy these servers up, because again, a server sitting in a box in shrink wrap and not being deployed is costing the company money. The whole purpose is to get your applications spun up on these servers and start creating an operational environment so that you can basically at that point drive or basically run your entire enterprise operation. All right, if we go up to the other drawer location now, in this case is drawer number 17 location. Again, we have the same functionality that we provide in both Dell servers, HP servers, Supermicro servers. we have all of this same functionality across the board. So it's not unique to basically third-party devices. We provide this to all devices that are connected inside SuperCloud Composer. Again, you have the same functionality, ability to add in things manually. Now, on the discovery piece of this, we've built into our BMCs automatically SSDP discovery. So by default on the BMC, it's turned on. We have two methods within to discover devices within SuperCloud Composer. For Supermicro related devices, we have SSDP, and we also have a ping spray itself. So differences are third-party devices don't implement those capability, and so we provide manual operation for you to add within the drawer configuration of basically PodView. Okay, so that's a little bit on PodView. Probably went a little bit more detailed than what you're looking for, but wanted to give you some idea of differences between third-party support and what we provide in our Supermicro platforms themselves. Okay, so the next thing we're going to look at is really the hallmark, again, of SuperCloud Composer is really the life cycle management of servers, right? That's where we predominantly as a server architect would spend most of our time. And we provide that information into what we call a system list, which is really called compute. So when those servers get registered within PodView, they now become available within the system list. If you do not define them or go through the registration process, they won't show up in this particular compute list. They'll stay, again, on the discovery pool and be waiting for you to make the decision to register them within basically PodView. So once they're registered within PodView, they now become part of the jurisdiction of really our platform of management and lifecycle management. So the first piece of this where you're looking at basically registration within PodView is really your day zero lifecycle management type of activity. So day zero would be you're taking it out of the shrink wrap box. We've sent it to you through our CBurn process. The server's ready to go. It's gone through exhaustive testing within Supermicro's production. And then you get it. You basically unpack it. Becomes in crates, sometimes with depending on the level of service you have. We would send you a whole entire rack that is completely populated with servers based on our rack team doing their L11 and L12 service. So if that's something you're looking at, I would certainly recommend you reach out to our rack team. They're the experts in creating the whole cable plant for you, the whole cabling diagram that they provide when they send a rack to you. It's amazing how they neatly pack in all the cables. It's really a professional job, and they do a top-notch job for our customers of providing this level of service that you're actually looking for. And we are continuing to ramp up our production facilities to support, say 3,000 racks a month. So they have it down. They know exactly what they're doing, and they can pump these things out. And it's just an amazing job they do over on the rack team. So what you're looking at here is the compute list, which provides you all the lifecycle buttons across the top here. So we provide that buttons conveniently located in one place. You don't have to navigate around and find out, okay, what does this button do? What does that button do? We provide tooltip information. We do firmware updates. We do, erasing of simplified storage, which would be a drive on your system. We do UID. We do power management. We do a BMC unit reset specifically for Supermicro gear. Tag management, deploying an operating system, so on and so forth. So a lot of information or buttons are available to you to perform your tasks. We also have on the left-hand side here in the PM rack itself, we again provide you the tree view information. So nothing changes from what you saw in pod view versus compute. We still provide that tree architecture you're looking for which particular server is connected to which rack slot unit. And then you can click here if you like to click in any of the BMCs. It'll launch you into the BMC itself. So we want to look at really ProLiant PowerEdge server, which is the R640. So if we click here at this point, immediately we'll get into what we call the physical asset collateral of this particular server. So this opens up a lot more detail within the Dell server itself. Again, the buttons on the top for lifecycle management are still provided to you, so you don't have to navigate back to the compute list and do those, execute those buttons that you want to use for lifecycle management. We provide them up on the top, the same place. Again, unified user experience is important to us here at Supermicro, so we think through a lot of this information here, all these processes that you want to look at, and we provide you a great user experience. So on the top here, we provide you with a carousel view, which is a high level of different types of components that are inside the server itself. Things like whether you have a local GPU assigned, whether it's attached GPU through what we call resource disaggregation, memory information, CPU processor, so on and so forth. If you stop here or basically put your mouse into the carousel view, it stops the scrolling. So if you saw the video previously, we identified two processors for this particular server. So it's a two-socket type of server. So there are two CPUs in it, and then and if you remember, we had 56 cores. So how did we get that 56 core? Remember, we went back into the previous video and had you walk the endpoint, and we pointed out where that attribute was within the endpoint. So we have these intelligent agents that collect or harvest all this important metadata, and then we organize it in a unified dashboard experience for you as a server architect inside the management platform itself. So again, looking at various important attributes that we put inside our unified dashboard is going to help you save you time. Of course, if you wanted to get all this information, you could walk and parse the Redfish endpoint, but that would take you time, and you would have to collect that information, maybe basically pump it to a file, and then be able to scan that file and find out how that server has been allocated, or how that server has been basically produced, right, or created, with all the components in it. So providing you that unified dashboard experience at scale is going to be very important in the enterprise to save time and basically money. All right, on the left-hand side, we open up all the various different components that are inside this particular server. So things like processor, right? So if you remember, we actually saw a Xeon Platinum 8176 CPU, and remember it was 2.10 gigahertz. What we discussed is that the Dell one, or the HP one, was a little bit lower in gigahertz rating. So again, we provide you with two sockets here. Both are 28 core for a total of 56 core. Okay, So there are other things we do to basically accumulate or basically provide you with a better feel for how your server has been actually produced or created. Things like the state, the health, all of this information is collected through the Redfish endpoint and actually provided to you from an end user experience or a unified dashboard. The memory itself also we provide based on Redfish endpoint data collection. You see here we're using a micron type of DIM, the serial number, device type. So a lot of this information can also be used for asset tracking to prevent potentially track of where your components are. And so that would be helpful if you have people that are maybe not ethical, that are you want to track as far as theft and different things like that. So you can provide that information. We will be dumping that out into a common delimited file or CSV file so that you can take that information, pivot it into an Excel spreadsheet, and potentially do maybe capacity forecast planning, right? Technology refreshes that exist within a life cycle of a server itself. Typically, it's about 3 years that you get on a server, and then you basically decide through the amortization to essentially, go ahead and perform a technology refresh. So if you wanted to look at the various different CPUs, we provide that information, different areas, NUMA regions, NUMA region 1 and NUMA region 2 per CPU. So that information is provided to you by clicking here and looking at the DIMMs that are available within each NUMA region. We also provide local storage, remote storage, adapter information, FRU information in DMI. And we can allow you to manipulate that FRU and DMI information if you needed to replace, say, the motherboard, or you needed an RMA, a part in. We provide the tracking for you to be able to go in and manipulate that particular DMI or FRU. This server happens to be reporting a critical event. So we have compliance and governance built into our platforms for checks and balances. Because this server is basically providing you with a critical alert, we don't go ahead and allow you to deploy an operating system. So that's a decision we made based on compliance and governance. We believe if a server has a problem, why deploy an operating system, right? So that's why these buttons are basically at this point grayed out. So we have compliance and governance built into our platforms, checks and balances to not allow you to perform action on a server, especially deploying an operating system, because it's reporting basically a health problem itself. Once you clear the health problem or fix the component that's causing the health issue, then we will go ahead and allow you to deploy an operating system from the pool and allocate it. All right, so that's on the Dell server, PowerEdge server. So let's go back to the tree view and let's look at the ProLiant server. So the ProLiant server is logging a warning error itself. Again, we don't go ahead and allow you to deploy an operating system to the ProLiant server itself. So I went up to the what we call the drawer level and kind of showed you a different look at the system list. The system list itself provides you a location of basically the drawer. If you were to go up to the next level, which would be at the rack level, of course, we would provide you with all of those servers that are associated with that rack. If we went up to the next level, would be the pod level, we would show you all the systems that are associated with that particular group. So you get the idea that we're traversing up the tree and providing you different information depending on which particular location you're at. If you're at the drawer level, you certainly look at just the drawer information. If you're looking at the rack level, you're going to look at all the drawers or all the rack slot units that are associated with that rack. And if you're going up into the pod level, you're going to look at all the racks associated with the pods, including rack slot units for each particular rack. So that is actually helpful for a data center to see specifically what kind of server or what they have in their physical inventory, so they know exactly how to perform the lifecycle management necessary within their operation. All right, so let's click on the ProLiant server itself. And when we click on the ProLiant server, we're going to come up with what we call the ProLiant DL380 Gen 10 server itself. So this is kind of giving me a little bit of grief here, not responding as quickly as I want here. So I had to do a refresh here. Made me a little bit of a glitch in my ISP here. Been having some trouble today with it. So what we have here is we have a ProLiant server showing you again the front view and the rear view, and then all the physical asset information that was collected with our intelligent agent parsing that metadata from the source of truth, being the ILO 5. You see here the BMC version is ILO 5 5v2.44, the BIOS version of U30, the manufacturer HP. It is a 2U form factor, so it will occupy 2 RSU slots within the rack. Product family is the ProLiant family, and so on and so forth. Memory size, detailed information, all the lifecycle buttons still up on the top here, and then also, of course, the carousel view. So nothing changes, whether it's a third-party device or whether it's a Supermicro device. We don't change any information here for the user experience. You get the same metadata that's provided universally across any server that's in SuperCloud Composer's jurisdiction. All right, so the other thing is if you click on the navigation view here, we will open up the sidecar information with information you're looking for again, information that was parsed through our intelligent agents to get that data. And you see here, if you remember, in the previous video, it was slightly lower in the gigahertz rating. It was a 1.70 gigahertz bronze type of CPU in here. Remember, the core count was that much less than what the PowerEdge server was. The core count was 6 for each particular slot, right? So there's 2 processors. So it's again a 2-socket, and we have 12 cores. Again, the carousel view is up here. A little bit more larger memory footprint on this particular server than the Dell PowerEdge. And we have also information here that were extracted here, such as NIC information. Now, I also want to mention to you, although this server has lots of NIC ports, again, the kind of information they expose within their Redfish endpoint, sometimes we don't have the detail we need, such as link state and various information. It depends on their implementation of what they basically provide in their Redfish endpoint that we can provide within SuperCloud Composer. Of course, if it's a Supermicro server, we provide this level of detail, right? Because we're leading the industry in Redfish implementations. That's why a lot of our customers are coming to Supermicro, because of our open standards base, what we're doing in Redfish from a BMC perspective, and what level of different kinds of options you can have within your hardware that is going to be tailored specifically to the kind of workloads that you're running. So that's why people are coming to Supermicro, because of those important things they need to be customized from Supermicro. All right, so again, information here also provided with FRU and DMI. I want to point out on the HBA side, we don't have any HBAs in specifically the ProLiant or the Dell server. Our HBAs are going to be provided in our 4 golden SKUs, which we refer to as Blade, Big Twin, DC Cloud, and Hyper. So we will expose out-of-band through Redfish our WWPNs and WWNs, so that you don't have to go into the BIOS and look at that information through the BIOS. It will be exposed out-of-band to you, and that will be very important for storage administrators to determine what physical HBA is connected within the environment, right? That they're logged in through a Floggy, which is a fiber login, or HBA login. You'll see later we'll come into a lot more detail on our fiber channel story in next videos that to follow. All right, that completes lifecycle management at this time for our third-party devices. Next time, we'll talk about deploying an operating system to a third-party device, which is Dell and HP. Thanks for taking the time to stick with me. It's been a pleasure showing you what we are building here at Supermicro. Thank you for joining, and we'll see you next time.